purchased when item X is purchased, expressed as X then Y. X is called antecedent of the rule. Y is called consequence of the rule. The confidence is calculated based on support value of X, but there is drawback. For example, it might misrepresent the importance of an association if beers are also very popular in general, like this. So beer is not associated with apple. And the last one is lift. This say how likely item Y is purchased when item X is purchased, while controlling for how popular item Y is. The lift is calculated based on support value of X and Y. If lift value more than 1, item Y is likely to be bought if item X is bought. If lift value less than 1, then item Y is unlikely to be bought if item X is bought. Okay, why we may know that there are measurement of analysis X then Y. After this, we will call X then Y is frequent item sets or rules. This question is, how do we generate the frequent item sets rule? Okay. So we have the some way is association rule mining or ARM is one of the ways to find patterns among items over transactional database. The most used algorithm to deal with ARM as a priori. It can generate frequent item set from which association rules are built. This algorithm is composed of two phases. First, uh, generate frequent item set and extract association rule from those item set. Because item set is not one item and with one item is more than one, then more than one. Okay. The example is 5 items in database. First, we generate the frequent item set from or subset of items in database, and we prune some infrequent item sets based on minimum support value threshold in the left hand side. And the second, we extract the association rule value such as support, confidence, and lift value for analysis. But there are limitations. The first one is spurious association or fake association. The support threshold might have to be lower to detect certain association. However, lowering the support threshold might also increase the number of spurious associations. And the second one is computationally expensive. Even though the a priori algorithm reduced the number of candidate item set by the prune method, but this number could still be huge when store inventories are large or when the support ratio is low. So this problem is generating frequent item set is NP hard problem because it is time consuming and some problems cannot be solved within polynomial time. For all n items, there are 2 to the power of n possible combination subset. So as a result, there are approximate methods based on an intelligent browse of the search space, providing a solution which may not be optimal but of good quality enough. In a short term with genetic algorithm optimization, the red zone is X and the blue zone is Y in the example. The solution is evaluated by fitness value in the green zone. Okay, I will brief the optimization shortly. Optimization is the problem of finding a set of input to an objective function that results in a maximum or minimum function evaluation. And the next one is genetic algorithm. The genetic algorithm were inspired by the process of evolution by natural selection. I will be explained in next section. The fittest individual or the potential solution from a population of possible solutions are selected for reproduction, and their genes are passed on to the future generation. This work has two objectives. First, this paper studied the impact of GA components such as chromosome encoding or the solution encoding and different crossover, mutation, and replacement strategies on the number and quality of extracted association rules. And the second one is this paper proposed a strategy to manage the population. The latter is divided in subpopulations. A GA is applied on each subpopulation by parallel programming. Okay. First GA component is chromosome encoding. You can call solution individual chromosome is any name. It's the same. This paper proposed to test two types of populations organization in chromosome encoding. The first one is the traditional encoding with different rule size of solution. Population contains solutions of the different rule size, and the second one different rule size of subpopulation or class. Each subpopulation contains solutions of the same rule size. Okay, let's look the first one. The first one is population contains solution of the different rule size. You can see the solution contain different item, and the last one represent the consequent part, and the others is the antecedents. And the second one is different rule size of subpopulations. Each subpopulation contain solutions of the same rule size. A subpopulation consists of several rules. Many items are considered in the consequent part. Hence, an index is used to separate the two parts of the rules. And a GA is applied on each subpopulation. You can see if we have n subpopulation size, then the K is over is all population is all number of population is n multiplied by n minus 1 divided by 2. Why to do this? Because we be sure to have several stool of different size and give preference to the smallest stool, which usually are the relevant ones. The strategy of distribution is made according to a decreasing arithmetic progression. And the second GA component is fitness or score calculation. Usually, support and confidence are used to evaluate rules. The fitness function can be defined as follows. Fitness equal alpha multiplied by support plus beta multiplied by confidence and divided by alpha plus beta, where alpha and beta are two weight parameters in range 0 to 1. The fitness value will be computed after some solution were muted.
That makes sense. Can you go back and
Yeah, yes.
alpha plus beta as a
Alpha plus beta. We can, the
for the maximum value of the fitness is 1 or not?
Yeah, is 1 and the minimum is 0.
The support and the confidence value gonna be 0 to 1, right?
Yes.
Okay. Let's say support is 1 and the confidence is 1. So the result gonna be alpha plus beta, and the fitness gonna be the maximum as 1, right?
Yes.
Okay.
And the third one is genetic operators. They have 4 steps. First, selection, crossover, mutation, and replacement. The selection, crossover, mutation, and replacement are applied on a population of chromosomes for several iteration or generation times. The first one is selection. There are many methods of selection, such as rank selection, tournament selection, elitism selection, and roulette wheel selection. But this paper randomly selects 2 chromosomes to cross over each other. After we random select the two selected chromosomes are crossed with probability to give 2 new solutions, such as finding the crossover point with popularity. This paper proposed to test 3 types of crossover. First, 1 point crossover, and the next one is 2 points crossover, and the last one uniform crossover. 1 point crossover is find the point of crossover and swap the rest of each other. And 2 point crossover is swap only the middle, and uniform crossover is swap by 0 or 1 mass. The next step is mutation. Before fitness will be computed, each chromosome is mutated with a popularity. The mutation consists of changing a random item in a chromosome with another value randomly. This mutation might generate a new association, leading to a diversification. In the example, the index of 35 before mutation is 1, and after mutation will be 0. Okay, and the last one is replacement. After fitness was computed, fitness value can help to decide whether the new chromosome will be added to the new population or not. This paper proposed to test 2 replacement techniques after mutation. The first one, a parent is replaced by its son if son fitness is better. And the second one, the worst chromosome in the new population is replaced by the new one if its fitness is better. For this purpose, several datasets of different sizes are used. Each report result is an average of 10 executions. They have the small dataset and medium datasets to test this experiment. The first experiment is rule type test. This result of the execution of GA with the following parameter is rule type. We test 1 rule and several rules. And crossover type is 2 point, crossover rate 0.9, mutation rate 0.1, replacement type, replacement of parents, and population size is 50. Population type, they use subpopulation, and the number of interaction is 100. And the left hand side is the 1 rule encoding, and several rule is the many consequent part. And this is the result of rule type test. The first encoding or one rules give best result with the small dataset C20D10 and medium one C73D10 since it gives highest fitness. Otherwise, for the rest, the two encodings are almost similarly with a slight advantage for the first one. In the follow test, we use one rules encoding as it gives association rule with the best quality. And the next one, the test the populations organization test. Uh, use one rule type. Crossover type is 2 points. Crossover rate is zero point 0.9. Mutation rate is zero point 0.1. Replacement is replace of parents. Population size they test 100 and 200 population. And population type they test population and subpopulation. And iteration is 100. Okay, the result of population organization test as shown in figure 4, figure 5, and table 2. Okay, let's see the table 2 first. Table 2 show that organizing the population in class gives usually better confidence. One can notice that increase the size of population give more rules and increase confidence. But we obtain more rule with one population than with divide population. And the next one is figure 5. Figure 5 shows the average rule size or the length of rules. When using the two types of population, one can notice that the average of the average is higher for the population organization in class than the other ones. This is due to the convergence toward rule of the smallest size. Moreover, we present the different result obtained while varying the number of class. In the populations, the number of classes influence the number of extracted rules, but not on the average fitness. So we have more rules if we reduce the number of class. And the next test is crossover test. We test 1 point, 2 point, and uniform crossover. And the result is on figure 6 and figure 7. Figure 6 and figure 7 show that the 2 point crossover gives more often the best result in terms of the number of obtained rules and the quality of rules or fitness. And uniform mass crossover give more rules than the 1 point crossover. So they use the 2 point crossover in the next experiment. Next experiment is replacement test. They test the replacement type is replacement of parents and replacement of births. Average fitness is best when using illicit replacement as worse individuals are replaced by better ones. Furthermore, this type of replacement can lead to convergence in the number of items contained in the rules. A small set of items lead to the same appearing item in all the rules. And moreover, the performance tests are conducted to measure compare the execution time of GA in sequential and parallel case. The aim is to show the impact of CPU parallelism and type population on execution time. This paper presented the results of three GA execution types. The first is sequential execution or SE, or we can call traditional GA. And the second is computation of parallel fitness on CPU or PE CPU fitness. And the last one is the parallel GA algorithm on subpopulation, or you can call PE CPU classes, such as uh, parallel crossover mutation and we test in the population type is population and subpopulations. Okay, this is table 5 is the execution time according to sequential and parallel execution on the two types of populations. Okay, let's see. The table 5 shows that PE CPU fitness is more advantage or for the last instant. Indeed, for the small instant, the execution time is 12 times slower than the sequential one. So then if we use the parallel, we use for the last instant only. And if we focus the slope of the evolution of the two methods, sequential and parallel, in the both figure are similar, but in the sequential execution or the blue bar, one population is faster than execution on subpopulation. Okay, the last one is conclusion. Paper contribution is to study the impact of different strategy of GA component since different strategies are used in the literature, but in author's knowledge, there is no previous work for comparing this strategy. This comparison is done according to the number of rules obtained and the fitness. This paper proposed to organize the GA population into subpopulation. The conducted tests on this strategy show that this organization give interesting result on quality and execution time. And the last one, parallel execution on CPU is also studied, and the result, the test on different datasets show the interesting gain in time execution. Any question?
And
Yeah.
how to divide the subpopulation
How to divide the subpopulation? Okay, give me a minute.
and population of
Yeah, we divide the subpopulation by the pointer or index. You can see the row. The one row is subpopulation. My pointer. Okay. Okay. This is one subpopulation, and in some one subpopulation has many solutions. We can create the array in the different size, or we can create by the pointer.
I just have a simple questions. As you previously mentioned, because there are no previous work using the GA in doing associations. So I just wonder that The reason that there are no previous work using the GA because normally we don't use the GA in doing association, right? So I just think about why other people just don't use GA in doing association. There must be something, right? Because the GA is well known for a long time ago, and associations many people doing in the data mining, but just no one uses it. I think there must be some reason on that. Can you explain why normally people just don't use GA in?
I think because the GA cannot find the optimal solution, but it's good quality enough. If we use the a priori algorithm, we can find the optimal solution, but it takes more time than GA. But if we have the large database, we can reduce the time of execution by GA.
Okay, so you mean that even the solution might not be the optimal solutions, but the GA can reduce the time and the result is acceptable, right?
Yes.
And
Yes.
Did this paper for subpopulation on campus do like that before? Because this paper is 2019.
2000
มีคนทำสับป๊อปก่อนหน้านี้ไหม
2019 support before this is I think no one to do this. Everyone do by the different rule size.
สับอะไรจะสับมันคือสับ population คือจำนวนไอเทมมันทำในการแยกว่าถ้ามีไอเทมเท่ากันก็เป็น GA ของใครของมันแล้วก็เอารวมกันเลยเร็วกว่าคือฐานว่าคือฐานมันโอเคมันเลยเร็วมันเลยกว่าเพราะว่ามันดีไวซ์ออกเป็นแบบไซส์ของไอเทมนะ
ว่ามันจะต้องบานที่มีสองบานที่มีสามมีสามและสาม
Next slide.
Next slide. Yeah.
What sub four?
มันสั้น
Is sub 4 is subpopulation 4.
มันเปรียบเทียบฟิตเนสระหว่างสับหนึ่งกับสับโฟร์คุณทั่วไปทำยังไงให้มันน้อมเมื่อไหร่ ใช่ว่าฟิตเนสมันน้อมเมื่อไหร่มันอัน
ครับ
เอาทูน้อมเมื่อไหร่ฟิตเนส between sub 4 and sub 1
The fitness calculation was normalized by divided by alpha and beta. This equation, every population was normalized. Because fitness value is between 0 to 1 only.
ใครถามไหมอาจารย์แบงค์ถามไหมเย้อาจารย์แบงค์เคลียร์แล้วกัน
yeah clearly presentation
โอเคครับท่าน
ครับขอบคุณครับ thank you everyone
ใครถาม
เมื่อกี้ผ่านแล้ว
ถามเลยถามเลย
ถามสิ
ถามเลยครับ
เดี๋ยวก่อน
อ๋อ how to parallel
yeah
okay the first one we parallel by subpopulation this called parallel by class and next is and one parallel is parallel fitness we parallel by calculate the individual in the same time in the subpopulation in the same time. Okay. First parallel is parallel by parallel subpopulation in the same time, and the second level we parallel by the same each individual or each solution in the same time. Okay.
You mean if we mention like a programming code, you mean this process on the same code but different data, right?
Yes, different data sets.
I see. Yes.
Okay.
เจอกันที่สัปดาห์หน้าครับสัปดาห์หน้าใครพรีเซนต์โอวานอ่าน
only one
โอเคโอลิวาน
โอลิแบง
โอลิวานโอเคโซโล่
โอเคครับโอเค
เปิดท้ายตั้งแต่5 นาที
วันโทรก็จะเป็น แต่ว่าเป็นวิธีไปถามไปอีก
เกี่ยว
ที่วันนี้ซ้อนกันเพราะว่าพี่เล็กเหลือนิดเดียวโอเคครับ
โอเคI think we had an appointment อาจารย์ภาษากรใหม่ an appointment yeah mention 30 do you know the time slot to one
and now
no plan yet
after that we will make queue by
so you guys will make a schedule in the afternoon okay I think
You haven't had one to try.
no I don't have any progress at all so take your time
thank you ครับขอบคุณครับ
อันต่อไปอันจะซูมมาไหมหรือยังไง
ตอนบ่ายเหรอ ซูมก็ได้ครับ
ไม่ถ้าอันจะซูมต้องบอกก่อนเพราะว่าอาจารย์จะอินดิวิดวลเลย
อ๋อ
ก็ติดต่อมาด้วยแล้วกัน
ใช้ซื้อ OR ไหมจริงเหรอใช้ซื้อหรอพี่ที่ไหนซื้อตอนเท่าไหร่
ได้ไม่ได้
แบบ
ก็แค่ถ้าต่อครูเข้าซื้อมาเครื่องครูได้รอโน้ตบุ๊กกันแน่
อุ้ยน้องนี้แบบ
ได้
แต่ตอนนี้แพงแล้วอ่ะ40 กว่าก็มา